So weight is the force of a planet's gravity on an object. And if we were to look at the weight of an apple on Earth, then it would have a weight of around about 1 Newton, because it has a mass of about 100 grams. But if we brought it all the way over to Jupiter, which has a lot more mass than the Earth, then our apple would still have a mass of 100 grams, but it would have a weight of nearly 2.5 newtons. 2.5 times the force pulling it down, and that's because Jupiter has a lot more mass. It has a higher gravity. In fact, we say that Jupiter has a stronger gravitational field strength. Gravitational field strength. We can measure the gravitational field strength, which has got a symbol little g, in terms of how many newtons it exerts for every kilogram. So here we've got 100 grams, so that's about 0.1 kilograms. And on Earth, the gravitational field strength is about 10 newtons for every kilogram. So that means we've got 10 newtons for 1 kilogram. We've got 1/10 of a kilogram, so that means the apple weighs 1 Newton. But on Jupiter, Jupiter's gravitational field strength is about 25 newtons for every kilogram of mass. And so our apple, which weighs 1/10 of a kilogram, will have a force or a weight of 2.5 newtons. The weight of an object can therefore be calculated using this equation, which is given in your exam equations sheet. So the weight is W. The weight is W, and that has units of, well, it's a force, so it has to have units of newtons. M is the mass of the object, and that is always has units of kilograms. And G is this gravitational field strength of the planet we're on. So the gravitational field strength, and it's got units of how many newtons there are per kilogram. It's telling us how strong the gravity field is on the planet. On Earth, it's about 10 newtons for every kilogram. But depending on what planet you're on the Moon, for example, it's about 1/6 of that. So it's much weaker.